In this lesson, section 7.1.2, we will be simplifying rational expressions. Now, although it is very common now in math textbooks to see this process described as simplifying, most of us are familiar with the phrasing reduce to lowest terms. And with traditional arithmetic fractions, this would be kind of like if you had 4/6 and you could divide both the top and the bottom by 2 and get 2/3. This is called the simplified version. We traditionally have called it the lowest terms version. So we're going to find a common factor and divide it out. In order to do that, for each one of ours, we will consider factoring the numerator and the denominator and dividing out any common factor. All right, for the first one, look at this. When the instructions say simplify the expression, check to see if you can factor the top. And you cannot. X plus 3 does not have a common factor. It is a binomial, but it is not squares or cubes, so there's nothing I can do. The denominator, there's nothing I can do with it either, but I notice that it is equivalent to the numerator. The commutative property says that 3 plus x is the same as x plus 3. Now, when you see that something cannot be factored, I recommend that you put it in parentheses because it is an entity that cannot be separated. It is x plus 3 times an invisible 1. X plus 3 goes into the top once, x plus 3 goes into the bottom once. This is 1 over 1, which is equal to 1. You could have simply said any quantity over itself is equal to 1. Make sure that you notice I did not divide out the x's. X is not a factor of the top or the bottom. X plus 3, the quantity, is a factor. All right, let's look at the next one. We have x plus 1 over 1 minus x. Now, x minus 1, there's no common factor. It is a binomial. It is a difference, but it's not the difference of squares. So it cannot be factored. We'll just put it in parentheses. The denominator is the exact opposite. And just like if you had 5 over negative 5, it's equal to negative 1. Anything over its opposite is equal to negative 1. When these are opposites, they divide out, leaving a negative 1 somewhere. It could be on the top or the bottom, but it is equal to negative 1. So when you divide out opposites, you always get negative 1. When you divide out the same, you get positive 1. All right, let's look at number 3. Simplify. You need to factor the top, factor the bottom, and divide out common factors. The numerator, there's nothing I can do. It is 3. The denominator, there is a GCF of 3, and if I factor out a 3, it goes in there 2a times, and 3 goes into negative 9, negative 3 times. 3 goes into itself once, 3 goes into itself once. And I'm not sure why that keeps doing that. That leaves me with 1 over, don't write the 1 times, just put 2a minus 3. You can leave it in parentheses or you can take it out. Remember, you can only divide out. Some people say cancel out, but it's actually divide out factors. It must be a factor. Let's look at number 4. I have 7x minus 28 over x squared minus 4x. The numerator, I see a GCF of 7. If I factor out the 7, it goes into 7x x times. 7 goes into negative 28, negative 4 times. Over Here I see a common factor of x. X goes in there x times, x goes into that term, -4 times. Do you see any common factors? The binomial factor x minus 4 is in common. And that gives us 7 over x. Let's look at number 5. I have x plus 3 over x squared minus 6x minus 27. The numerator, x plus 3, there is nothing I can factor out of that. The denominator, I should be able to use trial and error. There's no GCF, but it is a trinomial. The last sign is negative. That means 1 plus and 1 minus. I have x and x. I need factors of 27. Is it going to be 1 and 27 or 3 and 9? Since I need a difference of 6, it's 3 and 9, and the 9's going to go with the negative. So you're going to use all of your factoring skills. You have a binomial factor of x plus 3 in the top and in the bottom. Always leaves a 1 behind. That gives me 1 over x minus 9. All right, let's look at number 6. Simplify. That tells me I need to factor to see if I can reduce. The numerator, I'm just going to work on the numerator for a minute. I have 3x squared minus 8x plus 5. There's no common factor, but I'm going to work on my trial and error. The last sign is plus. That means it's either plus plus or minus minus, and in this case, it's minus minus. I know I need an x and an x. 3, you only have a choice of 1 and 3. 5, you only have a choice of 1 and 5. My goodness. Where did all that go? I must have touched something. So sorry. So that gives me, I have a 1 and a 3. Now, where I put this, it will either work or it won't. So I put in a 1 and a 5, and let's see. Let's check the outer product is negative 5x. The inner product is negative 3x. Those add up to be negative 5x, and that's good. So this was just my little factoring work. So the numerator has become, I'm not going to call it 1x minus 1, I'll just call it x minus 1 times 3x minus 5. And I didn't make a mistake, not because I don't have the answer written down, I was just lucky. All right, the denominator is x minus 1. There's nothing I can do. I see a common binomial factor of x minus 1. Never just reach into parentheses to get a term. It's the whole thing or nothing. What that leaves us with is a 3x minus 5 over 1. We don't put the over 1, so there's our answer. All right, let's look at number 7. Give myself a little bit more room. The numerator is x squared plus xz plus 9x plus 9z. I don't see a common factor in all terms, but I do notice that there are 4 terms. So I'm going to do grouping. What's in common in the first group is x. If I factor out an x, it will leave me with an x for this term, and it will leave me with a plus z. Plus, here I see a common factor of 9, and it will leave me with x plus z. I see the common binomial factor of x plus z. I'm going to put it out in front. That leaves me the other factor of x plus 9. The numerator has factored into, this was all just my factoring work for the numerator. I have x plus z times x plus 9. The denominator is simply x plus 9. Can I reduce? Yes. I have a common factor of x plus 9. That leaves me with x plus z. You can leave it in the parentheses or you can take it out. And it's over 1, and we don't need to write over 1. So anytime you're asked to simplify, you need to factor. Factor. Number 8. This is our last one. I'm going to do my work on the numerator. I have x cubed plus 216. Now, there's no common factor. I see an x cubed, so it makes me think that 216 might be a perfect cube, so I can test that. And sure enough, 6 times 6 times 6 is 216. So this is the sum of cubes. The sum or the difference of cubes, either one, factors into a binomial and then a trinomial. The cube root of x cubed is x, keep the sign. The cube root of 216, I used my calculator to find out it was 6. To build the trinomial, do you remember, square, x squared, change the sign, now it's minus, product, 6x, and square, plus 36. All right, this is just my factoring work. The numerator is, I don't need it over that far, x plus 6 times x squared minus 6x plus 36 over x plus 6. The common factors are usually very obvious. Once again, I'm left with a factor only in the numerator, so it is x squared minus 6x plus 36. It's over 1. We don't write down denominators of 1. If you feel more comfortable leaving it in parentheses, you can. All right, so to simplify a rational expression, you're going to factor the top. If you can also factor the bottom, you do, and then divide out common factors. You'll get to continue practicing with this.